Welcome to T.Machinery, where giant machines are built to conquer steel. Before us stands the new Hoisler plate bending system, one of the most advanced and powerful machines in the world of heavy plate forming. This machine is designed to handle massive steel plates weighing tens of tons, used in shipbuilding, offshore structures, and energy installations. Inside the vast hall, its sheer scale compared to humans is a striking reminder of engineering power at its finest. The bending process begins. A heavy steel plate weighing many tons is fed into the rollers. Under enormous pressure, the plate gradually curves into the perfect radius. Every movement is precisely controlled by hydraulics and electronic sensors. The rollers adjust within millimeters, ensuring a consistent curvature across the entire plate length. This is raw mechanical power, thousands of kilonewtons transferred through massive steel rollers. Steel, known for its rigidity, is now forced into smooth arcs, obedient to engineering control. It is through this process that cylindrical structures, storage tanks, and offshore wind towers are made possible. Without such bending machines, modern heavy industry could not exist at its current scale. After each cycle, engineers carefully verify curvature and dimensions. Precision is critical. Even the smallest deviation can disrupt assembly later on. Here, the balance between brute force and human accuracy defines quality. At T.Machinery, the standards are uncompromising, ensuring every component meets global industrial demands. Each bending cycle may last hours. From a flat slab of steel, the material slowly transforms into a curved section, ready to be welded into massive cylindrical structures. This is the first step in building large-scale projects, from ocean-going vessels to offshore platforms and towering wind turbines at sea. At the heart of this colossus lies a powerful hydraulic system. Gigantic cylinders generate forces of thousands of tons transmitted through the rollers. This represents modern mechanical engineering at its peak. Precise design, durable materials, and electronic control working in perfect harmony. Bending is not only about raw force, but intelligent control. From the central console, engineers monitor every parameter: applied pressure, roller angle, and feed speed. All data is recorded and analyzed in real time, guaranteeing consistency throughout production. It is the seamless integration of traditional mechanics with digital technology. After repeated passes, the flat plate has transformed into a precisely curved structure, ready for welding and final assembly. Watching this machine at work shows us a simple truth. With technology and ingenuity, humanity can shape even the hardest materials to its will. At T.Machinery, every finished plate is more than just a shaped piece of steel. It is proof of engineering mastery and human determination. From here, these sections will continue their journey, becoming part of colossal projects on land and sea, driving energy, transport, and industry for the future. This is where mechanical power and human intelligence converge, forging miracles from steel. In industries such as oil and gas, chemicals, and food processing, the vessel head is a key pressure-bearing component. We follow the full process of shaping a steel vessel head, from dishing, forming the dish contour, to flanging, creating the rounded knuckle edge. The starting blank is a circular steel plate cut precisely to diameter. A crane sets it on the manipulator, a support table that can move and rotate, positioning the blank under the pressing head. The dishing begins. A large punch head plastically deforms the steel at the center, then gradually moves outward in a spiral. Each stroke flows the material a little more, bringing it closer to the required crown radius. By rotating the table, deformation is distributed evenly. The press makes dozens of concentric passes, each slightly deeper, to avoid surface cracks and reduce internal stresses. Gradually, the plate changes from flat to concave. The edges start to tilt downward, an intentional step, since the next stage will bend the knuckle radius and form the correct flange height. When the design depth is reached within tolerance, the dish is removed from the dishing machine. At this point, it still lacks the flanged edge, a profile that the next operation, flanging, will complete. On the flanging machine, the dish rests on support rollers. A spherical forming roller presses at the rim, while coordinated movements of rotation and pressure gradually pull the edge downward, shaping the knuckle. Flanging requires high force but fine control. The knuckle radius defines how the vessel head resists pressure and distributes stress. Too small and the steel becomes brittle. Too large and the head grows heavy. Computer control ensures the edge bends smoothly without ripples. With the knuckle radius complete, the vessel head now matches the design profile. It is ready for the next steps: edge preparation, dimensional inspection, and possibly heat treatment to relieve stresses. In just minutes, heavy machinery transforms a flat steel plate into a precise pressure-resistant vessel head, a critical part at the heart of countless industrial systems. In shipbuilding and heavy industry, massive flat steel plates must be precisely shaped into complex curved components. This process is carried out by a specialized hydraulic press, known as the Neyland press. First, the steel plate is firmly secured. The clamps prevent any movement during pressing, ensuring maximum precision. As the hydraulic cylinder descends, tremendous force is applied to the surface. Under this pressure, the metal gradually deforms, shifting from flat to curved. In just seconds, a thick steel plate starts to take on curvature, the foundation for a bulbous panel used in ship construction. To achieve the required curvature, pressing is performed at multiple positions. The operator shifts the plate, allowing the machine to evenly shape the entire surface. Each press is like a powerful stroke. Small sections are bent one by one, gradually merging into a seamless curve. Slowly, a three-dimensional form emerges. These complex curves are essential for structural strength and hydrodynamic efficiency. The process requires a balance of machine power and human skill. Even the slightest error in angle can distort the entire component. Each pressing motion is carried out methodically, like steady footsteps. Parallel strokes build up a precise overall curvature. What was once a flat surface now reveals graceful curvature, the key step in turning raw steel into a refined industrial part. To ensure uniformity, the steel plate is repeatedly repositioned. Each adjustment is crucial to achieving precise geometry. The immense pressure bends the steel bit by bit. These gradual transformations form the basis of a strong, three-dimensional shape. Force and meticulous adjustment work hand in hand, turning rigid steel into a streamlined hydrodynamic structure.
Dat moet met stempelen doen.